Guys, welcome back to my YouTube channel. In this very video, I'm going to share with you three main faults that may arise whenever a magnetic contactor is in use. Now, when you are using this magnetic contactor to operate a load, either to turn a motor or a light on and off, there are three main types of faults that may arise. Number one is about the coil. Now, when you are using a push button or a selector switch to turn on this magnetic contactor and you realize that the magnetic contactor is refusing to start, it is not energizing, the only thing you have to do first is to come straight to the coil. And with the coil, we have A1 and A2. A1 is where you are supposed to connect your live wire, and A2 is where you are supposed to connect your neutral. Now, you could also see that we have a nameplate over here. This nameplate we have over here is telling you that this is AC duty contactor. And bear in mind that we have AC duty contactor and DC duty contactor. You have to check the coil voltage. We have 220 volts, 50 Hz, telling you that this is actually AC duty contactor. So when you turn on the switch or the push button, you push it, and this contactor is not energizing, it's not turning on. You have to first of all come straight to this A1 and A2 to check the voltage and also the ohmic value of the coil. We have a coil inside this magnetic contactor. So first of all, what I will do is to tune it to voltage. Now, if I have cables connected to this A1 and A2, what I will do is to check the coil voltage. That is the live and the neutral. So I don't have any cables connected to it. So what I will do is to go straight to the checking of the ohmic value. So what I will do is to select ohm. You have mega ohm here. You want to change it, what you have to do is to push this. You could see that we have three symbols. You have a diode, the beeping as the continuity, and ohm. Can push this select here. How the beeping. This is the diode. Okay, let's use this symbol, the mega ohm, or either this is auto range, so it is actually going to select the reading for you. So what we will do is to insert the leads to the terminals, that is the coil terminals. Now we have 0.55 kilo ohm, 0.55 meaning 555 ohms. That is the ohmic value of the magnetic contactor coil we have in here. That is the ohmic value of the contactor coil. Now, if you cannot tell whether the ohmic value here is correct or not, what you have to do is to use a similar contactor and check it. If the readings are right, you're going to be having a similar reading on that same type of contactor. So this is the first one that I checked, and this is the second one. So what I have to do is to connect the probes to this side. We have 0.556, that is 556 ohms. So I can tell that the coil in this magnetic contactor is in good condition. This is the first one that I checked. The coil is in good condition. With the checking of the coil ohmic value, if the ohmic value of the coil is near zero, it means that there's a short circuit. And also, if you're having infinite value, it also means that the coil inside this contactor has bent. If you're having infinite value or near zero ohms, meaning something is wrong with the contactor coil. Now we are having OL, haven't connected it to anything. So even if you connect it to the coil terminals and the OL is showing open loop, meaning something is wrong with the contactor coil. Now let's move to number 2. When you push the start push button or you turn on the selector switch, the contactor energizes. but the motor, either a 3-phase motor or a single-phase motor. Let's assume that it is a 3-phase motor. When you turn on the contactor, it is going to energize, but the motor is not receiving the right voltage. That is when you're supposed to check the power terminals. So number 2 is the checking of the power terminals. We have the inputs and the outputs. And with the input, that is where you're going to be seeing the line 1, line 2, and line 3. This side is a control terminal for the controlling of the contactor. This is not part. This is normally open. Number 13 and number 14. We are concentrating on the power terminals. I also talk about the open contacts we have here, the 13 and the 14. Now, when you turn on the contactor, it's going to energize. But the 3-phase motor, that's supposed to receive the line 1, line 2, and line 3 current. It's not receiving such current. That is when you're supposed to check the power terminals. This side is the input and the down here is the output. So what we have to do is to tune the meter to continuity. Already we have it at the ohmic side. So what I have to do is to use the beeping. That is the continuity. And also test it something like this. Okay, it is beeping. Okay, so what I have to do is to connect one side of the probe to the input, and down here is the output. We are checking the reason why the motor is not receiving the right voltage or the 3-phase voltage. Contactor is energizing, but the output terminals, you are not having the 380 volts to the motor or to the load. So what you have to do is to check for continuity. One side to the input and the corresponding line, that is the output. Connect this one to the output. Now what I have to do is to push the plunger. This is the plunger. So what I will do is to push it. Okay. Now the multimeter is beeping, meaning there is a continuity. What I have to do is to move it to this side and push it. This side too, there is continuity. Take it to the last terminal. That is the power terminal. Push it. This side is also beeping. Now this reading shows that there's a continuity throughout the power terminals. When it's energized, there's going to be a flow of current from this side to this side, from here to here, from here to here. If your load is actually a 3-phase load, there's going to be a flow of current from here to here, from here to here, from here to here. So from the readings that the multimeter provided, I can surely say that the power terminals are in good condition. Now, we have this normally open here. If you are using a push button to control this magnetic contactor, this 13 and 14 is where you are going to connect the hold-on wires. Here is where you are going to be using as the hold-on. So this is actually auxiliary terminal. Now, in order for us to check this helping terminal that it is surely normally open, what I have to do is to connect the probes to 13 and 14 and also push the plunger. This is open. So in this state, it is open. When I push it, it's going to close in that order. What I will do is to connect it to this side and this side. Hold it, push the plunger. Okay. It is beeping, and also there's a reading on the meter telling us that this normal open contact is also in good condition. So guys, that is how to troubleshoot a magnetic contactor. Whenever a magnetic contactor is in use, these are the 3 main faults that may arise. This type of contactor is having one normally open contact. Others two, you are going to be seeing normally open, normally closed. those are control terminals. So when the control side of your circuit is not working, what you have to do is to be checking these contacts. They normally open, normally close. If you have those contacts on the magnetic contactor, how to be checking those terminals. We use them for controls, either indication lamps or other load in the circuit. We use those contacts for such things. So guys, those are the three main types of fault that may arise when the magnetic contactor is in use. A fault coming from the coil, a fault coming from the power contact, and also a fault coming from the auxiliary contacts. That's the three main faults I've discussed in this very video. So guys, if you find this video helpful, consider subscribing to this channel and turn on the notification bell so that anytime I drop a video, YouTube is going to notify you. Thank you for watching this very video and see you in my next video. Bye bye.